Thanks everybody for joining today. We'll get started in a few more minutes. All right, we will go ahead and get started. Thank you everyone for joining the Semantic Kernel office hours. Like always, this session will be recorded and be available to you via our YouTube channel in the next week or so. So today, really excited. Hey, I'm Evan to share a little bit about what the team's been up to. We have a great deep dive session for you. A little bit later on agents. We talked a little bit about that last time. But before we begin, just a reminder, this is the US and EMEA office hours every week from 8 to 9 Pacific Daylight Time, where we can answer all your questions on Semantic Kernel, and we'll also give you some insights into what the team's been working on recently. If you can't make this or you have peers in APAC office hours, we do that the second Wednesday of every month from 4 to 5 Pacific time. All right, a couple updates before we dive deep. One is, if you've checked out our Learn site recently, you've seen we've done a few updates. We've also updated a new section for our vector store connectors. This is something new that's out there that's experimental still. But you can see a bunch of information in C#, Python, and Java. So go and check that out if you've started to use the new package that we have out there. We also have our roadmap always available because everything we do is in the public for you. So you can feel free to actually click on the link right there on the slide that you see, or you can also just go out to our GitHub repo and check that out under projects. And last but not least, we have a few new blogs since we all met last week. There's 2 new case studies you can check out from customers that have reached out. And if you have some amazing work that you want to show off, feel free to reach out to us, either in our GitHub issues or discussions. We'd love to highlight the work that you're doing. We also have one other call out, that last blog post. We talked about this actually the past couple weeks. Well, we wanted to highlight it one more time for you. So I'm going to turn it over to Mark to talk to us a little bit about the .NET kernel update that's coming next week. So Mark.
Okay, thanks, Evan. Yeah, so we've released a release candidate version 1.18 of the semantic kernel. So this is a pre-release, so you won't have automatically kind of like, picked this up unless you're opting in for pre-releases, and people typically don't do that. So you'd have to explicitly kind of like depended on this. We've had 1661 downloads of the package. So people have been experimenting with it. We've got a little bit of feedback. A couple of issues have been opened. We've been able to kind of like clarify the behaviors. So we're not seeing any regressions in functionality. And so far, we're not seeing any problems with the update. It is a significant update for us in that we're now depending on the Azure AI OpenAI V2 library and also the new OpenAI V2 library. So it's a big update, but I think for our customers, you're isolated from all of those changes, right? So it's a very, it's a pretty seamless upgrade within Semantic Kernel. But we have been cautious, which is why we did the release candidate. But right now, we feel like we're on schedule. So our plan is next Tuesday on the 27th, we're going to publish version 1.18, the official version with these changes. So yeah, I guess the call out is, please try out this package. And if you do run into any issues, let us know and we'll get them fixed before we release the update. Okay.
Perfect. Thank you, Mark. And the team's done a great job. If you have not tried it out yet, it's a very, very simple change. So go ahead and give it a shot. If you're using the .NET kernel, you'll see that we've abstracted away almost all those changes for you. All right, with that, we're going to turn it over to a bit of a deep dive today. Last time we spoke a little bit about agents. We're going to go even deeper here. So Chris and Evan are going to share a little bit about what we've been doing with the agent group chats in .NET and in Python. So Chris, take it away.
All right, thank you. So yeah, building on the deep dive from last week where we demonstrated kind of the different individual agents, chat completion agent and OpenAI assistant agents and how they might be utilized directly. We also have an agent chat concept that enables multiple agents to participate in a multi-turn conversation. Usually this is to accomplish iterative, complex tasks where they iterate back and forth. The one advantage to using group chat versus just manually controlling the agents is it does allow different agent types to communicate. So a chat completion agent whose chat is the conversation is managed in local chat history versus an OpenAI assistant where the chat is managed through the API thread ID, but they're both able to participate in the same conversation. Their history is kept in sync, so that allows you to mix kind of the low latency and simplicity of the chat completion agent with some of the compelling features for the OpenAI assistant agent, like file search or code interpreter. So you kind of get the best of breed is combining these things. In the agent framework, we have published two different agent chat classes. The first is a base class abstraction, just agent chat, that anybody can extend if you have custom scenarios. Say, for instance, if you wanted to, for some reason, integrate into a data source or some aspect of your app to help drive the conversation, that's certainly possible. But for a lot of cases, we have a concrete implementation for general use called agent group chat, which extends agent chat. And we're going to be showing off and demoing agent group chat today. Next slide, please. The agent chat behavior is based on two strategies. So, I mean, if you have agents participating in a conversation, you fundamentally need to know which agent goes next, what order they participate in the chat in, and then also, infinite loop is bad. It needs to know, hey, have I met the completion criteria? Have I achieved my goal? And so there's two strategies that control that, what we're calling the selection strategy and termination strategy appropriately. So there's a selection strategy abstract base class. So once again, you can customize and implement your own selection strategy. There's also, we have two concrete implementations, sequential selection strategy that selects the agents as named in sequential or round robin ordering. That's the order that they've joined the chat in. So it's kind of dependent on the initialization order. And then a kernel function selection strategy, which uses the LLM, potentially if you use a prompt function, to make that determination, which we can show off and demo in a little bit. The termination strategy, there's a regex termination strategy, which just uses regular expression matching to scan the assistant response for a match to determine has the criteria completed, which sometimes is okay, but I think we all know that the model's somewhat indeterministic, and sometimes this works like 90% of the time, but it can be a little brittle when the model decides to do something slightly different. And so there's also the kernel function termination strategy, which again can use the LLM if it's a prompt function to do more of a natural language complex uh, um, evaluation, which we'll show off. So, and in both cases, the kernel function selection strategy and kernel function termination strategy is going to incur a little latency because it's a round trip to the model if you're using a prompt function, but it does allow quite a bit more power than a pure code option, but both are available for your needs. And then aggregator termination strategy, which can combine, kind of create complex and or all or any conditions. Say, you probably wouldn't want to call the LLM a bunch of times, but say if you were chaining some different regex conditions, that's possible. Slide, please. All right. So in the agent group chat, as the agents are participating and posting responses, all of the responses, all the agent interactions are visible to the caller. It's kind of effectively a flat single level interaction, which does a decent job of kind of solving some initial scenarios, but we are exploring, based on working with different customers and how to support certain complex chat patterns, whether it's nested chat or if there's kind of a front room, back room type case. So that's something that's on our radar. As you are working with agent group chat, we're certainly welcome to for feedback and to learn from your experience, to adapt our support in a way that's impactful. The agent chat maintains a primary history. So in a case where the chat completion agent and the OpenAI agent, they each have the conversation history stored in their own modality, but there's kind of a global ground truth history that the agent chat maintains that's accessible. It's like get chat messages, I think, on the agent chat, and then but you can also access agent specific histories, because we want to make sure that none of that information is hidden. So same thing, you'd say get chat messages, but then just pass in the agent instance that you're curious in, and it'll retrieve those specific histories. Which can be good sometimes for debugging or just general visibility. Because the chat history agent is using in-memory history, the OpenAI assistant agent maintains its own truncation pattern in terms of you could have a thread that's 1 million messages long, and the API will always kind of manage the history in a way that fits inside the token window. But for chat completion agent, just as if you were using chat completion service locally, it's on the it has to be locally managed in terms of the history's growing beyond the chat, the token limit. We don't want that to mean that the chat's over and it's hit a dead end. So there's a history reducer that can be applied to the chat completion agent that can either just truncate the chat or provide summarization for the history beyond a certain threshold. So the history reducer can be used directly with the agent, but if it's present and you're using agent chat, it'll be automatically applied when the history meets the threshold. Also, so if you're using the agent chat and the OpenAI Assistant agent, it's going to automatically create a thread, which creates an issue where what if you need to clean up that thread or delete it? And so there's a reset method that will reset the entire chat state, including deleting the OpenAI Assistant thread. You could use it as a kind of a final completion gesture, or once it's reset, you can continue to use it again in a new state. If you're looking at the agent framework, we've talked about the agent abstraction and the group chat abstraction. You might notice there's one other abstraction, which is called agent channel. The agent channel maintains state. It's effectively a protocol adapter, allowing the agent chat to participate in, or the agent to participate in the agent chat. If you're writing a new agent based on the agent abstraction, you have to implement a channel as required. But for the caller, for somebody just using the framework, you'll never have to deal with the channel concept. So just FYI on that, if you're poking around on the code. As Mark mentioned, the latest functionalities in the RC1 package that includes Assistant v2 functionality based on the new OpenAI v2 dependencies, and then also a new Python package was just released. And then, as we mentioned last week, we're working on providing streaming support across the board. Chat completion agent has streaming support if you're calling it directly, but after the RC package publishes, we've got a change queued up that'll enable streaming support for the OpenAI Assistant agent and also for agent chat as a whole. So that's something the community's really been waiting for. So we're excited to get that out. With that said, we've got some demos. Share screen. Okay, and post some links. So the first two are .NET links. The second two are Python links that correspond to what we're going to show you today. So based on we saw last week, we showed a demo where there were two agents, in this case, two chat completion agents, iterating. One's the copywriter, the other's the art director. So we're going to leverage these demos and show them in using group chat. So this was the demo from last week. So we've defined the different agents concisely, created the chat history, and then from there, we explicitly create this loop where we're selecting which agent is active, invoking that agent, passing the history in, and then processing the responses, explicitly checking for approval, the termination criteria. So the selection approach and the termination approach is all explicit here, code written by the caller. If we look at sample 3, step 3 in agents getting started, it's the same scenario, the exact same scenario using group chat. And so in this case, creating the same two agents, and instead of creating a history and having that management loop, we just create a group chat, assign a termination strategy. In this case, we just extended the abstraction and made our own strategy that's doing a contains on a string, so very brittle, but enough to demonstrate the concept here. We only want to determine whether the completion criteria has been met for when the reviewer speaks. The writer doesn't get to determine the completion, only the reviewer. So you can scope the strategy to one or more agents. Then also you can limit the number of turns just so if things get out of control, there's some upper limit. So that's what's going on here through the execution settings for the group chat. In the constructor, we're assigning the agents. So once we do that setup, just add a message, input message to the history, and then invoke the chat, and it's off to the races. And it will continue until it meets the termination criteria, which could be this, or it could be when it hits the maximum iterations. We'll say that on the group chat, you can check the is complete property of the chat to so if it yields and it hits max iterations, but it without achieving the completion criteria, is complete will be false. But if it actually meets the completion criteria, then is complete will be true. So there is that visibility. And so I've translated that same demo using so in this case, we're just using a custom termination strategy. And by default, if you don't assign anything, the sequential selection strategy is active. So in this case, it's just iterating between the two agents. In the demo I'm about to show you, it's the same scenario, but I'm using the kernel function strategies where we're using prompt functions and the same agents. And so here we're passing the prompt function in the kernel that has a chat completion service, and we need to parse the result of when the prompt executes, and the chat histories formatted into that prompt, so you can explicitly say this is the parameter name for this prompt, so they're aligned. So that's what's going on here. Termination strategy, selection strategy. So this is going to be a little less brittle. I'm just calling the LLM for the strategy determinations. But once the chat's set up, the loop is exactly the same. We're just adding the user message and then invoking the chat. At the end, and in this case, using one OpenAI assistant agent and completion agent to demonstrate the interaction of two different agents. It's a little bit overkill because we're not using any OpenAI assistant tools, but just for the sake of the demo. But because of that, we're cleaning up the OpenAI assistant artifacts that are being created, resetting the chat, which deletes the thread, and deleting the agent. So that said, so here's where I ran it before. We can look at the output. I'll run it again, but effectively the user input inside the result parsing, I've output the different selections. So you can see in the result parser, I'm writing the results just so that we can see them for visibility. So in this case, selection strategy was called, and it said copywriter goes next. So copywriter goes next. Then the art director, in evaluating this response, it determined that the copywriter had not approved the copy. So the message is displayed, continue to proceed, and then the termination criteria is met. The chat's over. So if we run this, I've noticed, we'll see how many, sometimes the sample historically has gone on for a while, but lately our director seems to be pretty happy after just one or two. Oh, there we go. So same as we saw yesterday, except for in this case, we've got two different agents participating, and we have the kernel function strategies applied to group chat. So this whole conversation is kind of automatically being driven based on the strategies. This is good. It's just always better when the art director makes the writer work a little bit more. As we mentioned last week, when using the assistant agent, generally there's a little more latency than chat completion agent, just because there's more going on. That can also just randomly vary a little bit. Looks like this step's taking a second. There we go. So that's it. If we look at, I'll show it on GitHub. So for just showing this exact same sample using the code strategies, not the kernel function strategies, is step 3, and then the exact same scenario using the kernel function strategies is step 4. This is Python, and then .NET, exactly the same. So step 3 and step 4. So if you want to run these on your own, play with them, use them as a starting point, these are available for you. With that said, Evan's going to show us the same the group chat example in Python.
Thanks, Chris.
All right, thank you, Chris. Yeah, I just wanted to showcase. I mean, Chris showed the parity that we have right now on .NET and Python with group chat. As he just showed, you can find these getting started with agent samples, which are included as of 1.6.0, which we released yesterday. And we have a couple more agent samples. We're continuing to add more samples as we go. But I just wanted to highlight one of the fun examples, which is a mixed agent chat that interacts with a file that you provide to the OpenAI assistant agent. So we have this text file which contains some information about the Sahara Desert, and it's not too long, but we are going to provide that file as a file that the code interpreter can use in this agent definition. It's an analyst agent. And then we have a summarizing agent that is supposed to summarize the entire conversation for the user in natural language. So Krish was showing the ability to configure an agent group chat with specific agents, with termination strategies and selection strategies. In this one, we're just going to define the agent group chat object, and then we're going to invoke each agent just to run by itself. So that can be seen in this invoke chat. If we have a message, we add it, and then in the chat, we invoke it with the agent that we're passing in. And so this little helper code here is just going to show that we're expecting some annotation content out of it with this sample. I just want to show that we can get the file that it creates and then show you, because we're asking the agent to create a tab delimited file report of the frequency distribution of words in the file that we're giving it. So let's run that. I've noticed a little bit of latency with the agents today, and let's just give it a sec. So we can see that we're asking it to create that file report. It's going to go off and invoke this OpenAI assistant agent that's going to come back and with the response, and it's going to spit out a bunch of things with the code that it's writing to analyze the file. We can see here it's writing Python, and then it's come back and said the report is ready. You can download it from this particular link, and then we're just printing out what that word frequency tab delimited report is. So then the summary agent gets a chance, and based on the conversation history, it said, it's basically summarizing what we asked it to do. You can see it knows about the file, It's filtered and it's given us a good summary of all this verbose text here. So this is available in the mixed chat files. We have another mixed chat agents, which goes along with what Chris was showing. And then, as I said, we'll be continuing to add other samples as we go, so we can maintain parity between .NET or with .NET. So that's my quick demo right now, and I'll pass it back to Evan.
Yeah, perfect. Thank you, Chris and Evan. Awesome to see a few things. One, all the stuff working, which is great in Python and in .NET. Also having the samples out there in the repo for everyone to leverage. So thank you all for pulling that together. So this is the parts of office hours. There we go, where we will open it up for questions that the team can help hopefully unblock or give guidance as we need to. I did post a few links in the chat earlier, if you've seen those. So we tend to get a lot of questions on the roadmap. So we have the roadmap out there. And so let's get started. I see one question in the chats already around C#. And this is, and there's a link here, which is awesome, back to the Learn site. But the question is, hey, I'm trying to use Llama 3.1 model running locally on my machine. Are there any specifics to Llama 3.1 that you can recommend to get this running? So I think, Mark, did you take a look at this the other day?
I haven't looked at this particular one. I'm just sorry. I'm just looking for the question. Do we have Roger on the call by any chance? Yeah, let me take a look at the question. Sorry, I don't have the.
Okay.
Yeah.
No problem. All right. Yeah. Any other questions? Feel free to raise your hands or come off mute or put it in the chat.
Oh,
there was a good call out too, just real fast about the .NET conference that was yesterday. So if you missed some of those sessions, there was a ton of sessions on Semantic Kernel. So feel free to go check that out. All right, I see a hand up. Anastasia, do you want to go ahead and go?
Sure, thank you so much. So I have a kind of a general question. Is there some kind of guidance when to use the semantic kernel versus the prompt flow? Have our guidance changed since the beginning of the year? And another more general question, who is a good point of contact for the customer work, especially I know that previously there was a division within the team. I'm not clear on the current organization structure and who to reach out for Java and C# types of questions with the customer. Thank you.
Great questions. All right, so I'll answer a few of those. So I'm the best contact to reach out to. So I look over Semantic Kernel. So feel free to reach out to me if you have any customers with questions on C# or Java or Python, and I can route you to the right humans. For prompt flow, yeah. So Semantic Kernel, again, SDK, you can run anywhere. 1.0, so across all three kernels. So if yourself or your customers need to have an enterprise great SDK to do all the orchestration for calling out to APIs, calling into different vector stores, Semantic Kernel is the path forward for that. Prompt flow is awesome for evaluations, which we highly recommend. There's some awesome evaluation techniques there that are in Azure AI portal right now. So you can kind of see those under projects on the left nav. And that's all a lot of the prompt flow work that they've done. So that's what we generally kind of let our customers know around those pieces. Hopefully that's helpful.
Yes, thank you so much. And then a follow-up then to it for semantic kernel evaluation, how to tackle that aspect. You build it out yourself, or you kind of try to connect it to AI Studio and parse the traces, open telemetry.
Yep. Yeah, great questions. So that's awesome. That's one question we get a lot. So we use full open telemetry for all of our kernels. So with Python and .NET in particular, you can hook that up so that way you as a customer or your customers can use App Insights if they want with Azure Monitor. You can also use, Datadog. I mean, there's a New Relic. There's a bunch of awesome different third parties out there that leverage OpenTelemetry. Aspire, .NET Aspire is another one that's great. So you can use any of those. Use that data that you get in. We also support, and I'll put a link into the chat with some more details, but we also support the level of telemetry that you want to grab. So let's say you or your customers are medical, and maybe there's PII that goes into the chat history. You can strip out those type of pieces if you wanted to before it goes into your telemetry systems. And then you can feed that directly back into things like Promptflow if you want to do evaluations to see how things are going based on your actual telemetry over time.
And is there like a good example to follow just to share?
Yep. So I'll put a few items in the chat for you.
Thank you. Appreciate it.
No problem. Yeah. And then Mark, looks like we have some questions back and forth. Is there anything, Mark, you want to come off mute and ask?
Sure. Yeah. So just with regard to supporting OLAMA, we are working on a dedicated OLAMA connector. We actually have a bug bash for it later on today, so that we can actually release it. But if you're trying to use it with the OpenAI connector, you probably need to kind of look a little bit more closely at exactly what you're doing to see. Sometimes the settings need to be configured in a particular way in order for it to work. But yeah, so maybe we'll just kind of continue chatting about this, Ambat, and I'll get you unblocked over the next day or so.
Awesome. Thank you, Mark. Okay. Any other questions? Feel free to raise your hands or come off mute.
Yeah. Hi. I'm just wondering if you have any examples where using semantic kernel with tools where, let's say, rather than kind of executing code or anything, but let's say we have 3 or 4 tools. Like, for example, one could be an API call, another could be a chat, and then the user actually says something, and then we want to infer from that, okay, these are the tools that we should be using and executing it. Something AutoGen does, but I'm wondering if it's possible to do this with semantic kernel and the tools.
Yeah, I should be able to. Mark or Evan or Chris, do you want to talk about how we go and look at the intent and then find the right tools to call?
Yeah.
Kind of open up to the group if anybody wants to come off mute. If not, I can take it. I don't know if Chris or Mark, you want to talk about that from the agent perspective or from just the core kernel?
Yeah, so this is just sorry, actually I was trying to respond to the other issue. Sorry, the question here is about using function calling and how the model determines which functions to invoke. Is that correct?
That's right.
No, like like a scenario is instead of using AutoGen for much simpler, much more precise, where we know in a scenario, here are 4 or 5 tools. Like, for example, one tool could be calling Salesforce to get customer information. Another thing could be doing a search. But then the customer simply, let's say, throwing a conversational interface says that, hey, this is what I want to do. And then we understand the intent and look at the tools and say, okay, now let's execute these tools. Is that something that we can accomplish using semantic kernel?
Yeah, actually, that's one of our base foundational pieces that we came out with a year and a half ago. So we looked at the intents. You can do one of 2 things. You can either register the plugins, and the plugins have descriptions, and that could either be native code or remote API calls. So you give it the description of what that tool will do. And then we'll go ahead and you can do one of 2 things for planning. You can have the LLMs do the planning for you, and figure out what are those steps that need to happen, what chains in what order. Or you can hard code that also and say, no, this is the order that this needs to run in. So for your example, if it needs to call, let's say, Salesforce and then call some other steps, it could be if the customer or the end user says, okay, I want to look up, does this customer exist? I want to create an account. The first step may be go out, call Salesforce, do a query based on the user, if they have access to Salesforce and to the accounts that they have access to see, is that customer already there? What's their status? And then if they are there, then maybe you open up an account in an ERP system or something like that. So that's exactly what we can do with Semantic Kernel kind of out of the box. And then you can start to customize that a bit. So if we have some customers with 10,000 different plugins, right? You can start to filter that down and say, no, don't give me all of them. Give me the plugins based on maybe who the user is, what their intent is, what department or what division they're in. So you can start to filter that down.
Yeah, I mean, it would be good if, let's say, it's like similar to AutoGen or user agent, where once it cannot figure out having, talking back, hey, is this what you want to do, so that we can guide the flow of execution. I don't know if there are any examples that you could share, or is this something that you think we can do with the existing examples, or if you could point me to that would be great as well.
Yeah, Mark or Chris, we should have examples already for this, right?
Yeah, we've got a bunch of examples, so I'm going to paste a link into the chat in a minute. But if you're dealing with a model that is finely tuned for function calling, it can handle the reasoning, right? So based on the current user ask and the set of functions that are currently available, it can figure out which function to call next and which parameters should be passed, right? So we've got some quite nice examples where you can do things like provide a function, say, that creates a widget, and the widget can be different colors and can be provide different functionality, and then depending on what a person asks for, the LLM will generate a request to call the right function to create the right color widget, and it can basically work all of this stuff out. Even if what the user is asking for is, say, a different color from what the API supports, the LLM can kind of figure out that if I ask for a lime widget, I really want a green widget because that's the closest thing to it. So I'll include I'll paste some of those examples, but if you rely on allow the model to do the reasoning, you'll get very good results.
Yeah, we call that, that's auto function calling. So the models have specific endpoints for doing that type of work. Great question. All right, what other questions? These are good. Feel free to come off mute or raise your hand.
I have another question, if nobody else has. Some of these examples, I was wondering to use some of the new things that are there. Or even some of the old, like the escape function .text, to have. We had several examples. It was really easy and nice to use, where you call that config JSON and the escape function. So some of these examples that you're doing, I'm assuming we can do the same thing, right? Read the escape function .text as the prompt within the semantic kernel, or is that possible? And also the prompty, which is the new capability as well. How do we integrate that with the semantic kernel as well?
Yeah, so prompty is built in. I'll paste in a link to a sample so you can check that out. Mark, do you want to talk about the first one while I go and grab the sample link?
In terms of supporting prompting, yeah. So we have a plugin.
Not on prompty. I'll grab a sample for that. Can you talk about the using prompts in the text, the kind of more classic text files that we've had in the past?
Okay. Yeah. So there's we've gone through kind of like a couple of different iterations in terms of the format for prompt templates, right? So we started off with we two separate files. Like there was a prompt.txt and a config.json, right? So the config allowed us to kind of configure how the LLM, how the model would behave.
Yeah.
We've combined those into a single. We support also a YAML format now. And so we've got a single format that contains your prompt and all of the configuration associated with that prompt. You know, a lot of people find that easier to manage in their projects, and it's easier to kind of like version control, and you can give them better descriptive names. And we also support multiple different templating engines. You know, so we have our own built-in format. We support handlebars that allows you to do much more advanced stuff, and also Liquid as well. Like, you know, that was something that we needed support for Prompty. But you can add your own kind of like template format as well. You can also add your own file format if you wanted, right? So there's an example in the repository of a Markdown based format. And if you look at the implementation of that, if you wanted to structure your own prompt templates using your own syntax, you could build something quite easily yourself to do that.
So what would you recommend? Because I really like that function, that text and the config, because you know you could define all the parameters in the text and then you feed that parameter when you call the either chat completion. So what is the, you mentioned YAML, so what would you recommend that if I want that similar experience, what is the better one? What is the newer one that we should be using? Is it the YAML?
Yeah, the YAML format's much better, right? Because you know what you're finding at the moment is that within a project you could have, you know, 10 files called config.json, 10 called prompt.txt, and they become really difficult to manage to figure out what's what. But what you can do is you can create a, you know, my customer prompt.yaml, and then, you know, my partner prompt.yaml. So it's really easy to see what each one is. And the YAML format basically supports everything that the config.json and prompt.txt supported. So you're getting all the same functionality, but it's just easier to manage and easier to deal with in source control, all those sort of things, you know.